Hello, everybody. I hope you can all hear me. If you can't, please let me know right away. I don't want to go 45 minutes like the other day without realizing that nobody's hearing me, okay? So if anyone can confirm, I really appreciate that. I'll give you a second to give me a reply if you can hear me. As you probably know, I'm on vacation. I'm on the road, and so I'm in a different place. I don't know if you can hear me. Please confirm if you can. My voice is low. I don't know what to do about that. No way to, let's see. I've got it at maximum. I don't know. Maybe get closer to the computer. That's about it. That's about all I can do. You got to maybe turn your, your things on. Oh my God. Let's see if I'll try that. Let's see. Can you hear me now, or is that worse? Is that better, or is that worse? Am I getting echo or something? Oh, that's worse. Okay, that didn't work. What else can I try? I don't know what else I can do. I hope you can hear me. Otherwise, all you got to do is ramp up the sound somehow. I'll try to speak loud as I can over here. Anyways, I'm on the road. I'm on the road, and I'm on vacation. So I'm kind of improvising here in the middle of nowhere. Okay, we'll see how it comes out. The other day we left off with particles, particle man, people doing attraction with particles, and I'm saying it doesn't work. It doesn't work with particles. You can't do attraction with discrete particles. And the first lesson you must learn, this doesn't come from me, okay? First lesson you must learn is that quantum mechanics has already figured out that you cannot do gravity, attraction, pull. You can't do it with real particles. And that was the paradigm shift at the beginning of the first quarter of the 20th century, where they moved into quantum particles. And a quantum particle is not a corpuscle, is not a Newtonian corpuscle. That's considered classical mechanics. And I'll just give you a little anecdote that I've got, and that's that peer reviewer that once wrote that he doesn't even read anything related, anything that has classical mechanics in it. He immediately just throws it in the trash can. He puts a reject stamp on it and sends it back. He doesn't even read it. When he discovers its classical mechanics, he doesn't even touch it. And the reason for that is they already figured out you can't do it. They did it in every way possible. They cannot do real particles. And so a lot of these dissidents and dissident groups who are still insisting to this day to do things with real particles, well, they're off their rocker. They're ignorant of the situation. They're ignorant of what issues they have to answer. Okay? Quantum mechanics, the mathematicians, the mathematical physicists, in their entirety have given up on real particles. It's only dissidents who insist on real particles, and that's why no one in the establishment listens to them anymore, because these people simply have to catch up according to mathematical physics. And that's one thing where I truly agree with the mathematical establishment. Okay? You can't do it with real particles. He who still is thinking of real particles it just has no idea what he's got to answer. Okay, and one of the groups is the electric universe. The electric universe is the last one I was talking about, and they do particles, whether they know it or not. They talk about electricity, they talk about plasma, and what is that? It's particles. Why? Because they're using the quantum atom. That's why it's particles. Okay? So when you look at, dig deeper and deeper into their model, you get down to particles. Okay? There's no continuity. There's no elongated mechanism or agent. Okay? It's discrete particles. Okay, so let me illustrate what I was saying, because I didn't have the illustrations the other day. So let's start off here. This is what the electric universe proposes. They have this filament universe notion, all galaxies, all stars, even between planets and the sun, or planets in their own stars. What you see is this. This is what they have in mind. What they have is this filament universe. And these filaments, according to the electric universe, are electricity. And in order to produce this electricity, you need plasma. You need, like, the universe, the entire space in the universe filled with gas. Okay? And what I was saying the other day is that you need at least a -3 torr level to get electricity flowing inside a chamber. So you cannot do electricity without a -3 unless you reach a -3 torr level. Maybe you can do it with -4. You might get it even done with -5. For sure, you cannot get it what we have on the moon, -12, or with the solar wind, which is at the -13 level. Okay, so here you have the orbit of the Earth. Let's see, we're going to look at this example. Okay, here's the orbit of the Earth, normal orbit around the sun. We have no idea at this point. We're studying for the first time. We have no idea why the Earth goes around the sun. That's the question we're going to try to answer. Okay, so what does the electric universe propose? Well, they say the universe functions more or less like a plasma ball. And you've probably seen this somewhere, okay? And what are we staring at? Well, we're staring at a little ball that's got gas in it. And what I want you to notice is that the electricity is not consistent. It's not always in the same direction. It's just, in every direction possible. And, you can see that it's not organized, okay? And so now let's put the Earth in this kind of environment. In other words, this is the model that they say, that's the one they say, the universe essentially, or the solar system works more or less like a plasma ball. They say, yeah, there's electricity. Okay, let's find out. This is what I think. I try to illustrate it. This is what I think the Earth would look like going around the sun, with an environment of gas, of plasma, all around, at least as far as the solar system is concerned. This is what it would look like. And as you can see, there's no order, no direction to the electricity. It's just haphazardly in every direction possible. And how would you produce a smooth curve like the Earth going around the sun with this type of arcing? That's what we call it, just arcing, which is just a shot of electricity, a zap going in one direction, then in another direction, and in every direction possible, except in an organized, well-directed manner. So this is the issue. Maybe this is a better view that the electric universe would like for you to think of. Just a little zap going between the sun and the earth somehow. Okay? Electricity going between the sun and the earth. And even so, you can see it would be intermittent. It's like a lightning bolt. Would this create a smooth curve? And a better picture that they might have in mind, and again, it's for them to answer. I can only illustrate what I think they have in their minds. Here's another one. You have particles just constantly moving back and forth between the Earth and the sun. In this case, you would have to have a plasma gas, a gas in that region, a plasma ionized gas in there, and you would have the electron beads moving from atom to atom, from the sun to the earth, or vice versa. Sometimes it seems like the sun is the anode, and sometimes it seems it's the cathode, and sometimes it's the other way around with the earth. It's like they don't pay attention to these details. They just say, look, electricity flows between the sun and the earth. So are they referring to this, to electron beads flowing from one object to the other, one cosmic object to the other? This is the question a person should ask anyone from the electric universe if they really want to get to the bottom of things. Okay? Of course, the electric universe would like for you to think of it as this, just a flow of beads going from atom to atom, right, from one celestial object to the other. Okay? But even in this case, what do we have? Are we going to produce attraction with this? This is what they would like for you to believe, but then they show you the plasma ball on the one hand. Okay, here's the plasma ball. That's the model, and then they put the Earth inside this plasma, and they troll it around. It's very hard to believe that with a plasma ball you can get this type of organized flow. And then again, the question is, do you produce attraction with a flow of beads in one way, in one direction? Now, that's the electric universe version. There's another version that does not rely on electricity, which is another, probably the rest of the dissonance out there. And what they have is this. What they have is particles from the outside pushing it inwards. Sorry, it was had a little phone call. Anyways, you can see that the Earth is moving around. Why? Because it's hemmed in by some kind of particles that are pushing from the outside. You can call it the ether. You can call it whatever you want. What it is there's a push from the outside inwards. Okay? And so this is another version. Why it would be like that, why the particles would make such a circle, such a uniform circle or ellipse or whatever. It doesn't really matter what the shape is. But you can see this is a little awkward for them to portray the functioning of the solar system, especially gravity, with this type of mechanism. Okay, this one really resembles more what general relativity proposes, which is essentially a space-time that is bent. Here we don't have particles, but you have also like a shield or a depression, and the Earth rolls around that depression, and that's why the Earth doesn't fly out of the solar system. Okay, that's the mechanism of why the Earth rolls around forever. The question is whether that's what's happening out there. Now, a lot of these people say, well, a push is the same thing as a pull. And I think I covered that the other day when I talked about the flat earthers. And here's one flat earther, and he was suggesting that pull and push are the same things. In fact, he says simplicity of motion because there's faulty wiring in the brain of people. That's what he was referring to. That push and pull are two separate things. But no, any motion requires an applied pressure, 100% anything. Okay, so he's saying a push is there's no such thing as pull because even when you pull like on a horse, the rope is tied behind the back of the neck of the horse, and you're pulling on it, and you're pushing on it anyway, like there's pressure behind the neck of the horse. But that's absolutely not true. This gentleman really doesn't have an idea what he's talking about. Here I showed that if you stick a bubble gum to in this case, I just imagined a steel sheet, right? And you stick the bubble gum to its surface, it's not pulling from the back or around the sheet. What it's doing is pulling from the front. And so pull is not the same thing as push. And that's where we should start. These people don't understand the difference between pull and push. That's the first problem that they have. Okay. So how do we do it? Well, we do it with pull, and that's very simple. All you got to do is just tie the Earth to the sun, and the sun just twirls the Earth around. That's the mechanism we're proposing. Okay, and got a little ball here. Okay, tied to a little rubber band here, and this simple mechanism is why the Earth doesn't uh, get out of the system, the solar system. Very simple. Now you know what gravity is. Gravity is that every atom in the universe is interconnected, physically interconnected. And that's why the Earth doesn't fly out. That's why the moon doesn't fly out from the Earth. And that's why, whereas while the sun can twirl the Earth around itself, the Earth can twirl the moon around itself without any problem. Okay? And so the only issue, the only stumbling block people have is the tanglement of ropes. That's what keeps them from accepting this. And the issue, again, is not belief. The issue is understanding. The question is whether you understood the mechanism. You know, you have a cowboy with a lasso and he's rolling around, even in a merry-go-round, you know, he goes with his lasso. Well, that's the situation. One circle inside another circle, okay? Ptolemy's old epicycles. That's essentially how the solar system works according to the rope model. And again, the only thing preventing people from accepting that is how did the ropes avoid tangling? And my first answer to that is ask first the mathematicians, how do particles avoid colliding against each other? And then when you got that answer, then you come and see me. Because the issue is that no one ever raises that question with quantum mechanics. No one asks, well, how do particles from light over here, from this laser pointer, cross this other laser pointer? How they cross and go through each other? And nobody asks that question. But when we say, no, it's ropes, they say, oh, how do they avoid tangling? So let's get that straight. I won't answer the question until you tell me what answer the quantum mechanics gave you, okay? That's the first answer. There's a couple more, but that's the first one you got to answer. So don't ask that question unless you've got an answer with particles. If you don't, shut up. Keep your mouth shut because, you know, that's a question that you should have asked a long time ago to someone else, not to me, okay? That's my first answer. And I got a couple more, so be prepared. Anyways, this is how the electric universe proposes gravity, okay? And this is at the atomic level now. And they're saying, look, that all these atoms are aligned. Not only are they aligned, but they're not perfect circles. They're not perfect spheres. What they are is you have the positive nucleus, I guess the proton at one end and the electron at the other end. And if you aligned all these guys, well, then you have the positives in one direction, the negative in the other direction, more or less like a magnet. That's what they have in mind. And they say that that's what gravity is, that alignment of polarities. Okay? So that's their general notion. Okay? So if you got a hold of that in your mind, now we can go to the next step. And they say, look, imagine something like, you know, the sun and the earth, and there's a force that attracts them. Why? Because the outer atoms of the earth are aligned in such a way that the positive is on the outside, and the outer ones of the sun are aligned in such a way that the negatives are on the outside. And so now you have a attraction because you have positive attracting negative. This is the idea they have. Okay. And well, yeah, that's great on paper. How do we do this out there? I mean, are they saying that that there's a magnet between the Earth and the sun? Is that the issue? I mean, to say that positive attracts negative, they haven't explained anything. In fact, Ralph Sansbury, who came up with this idea, he didn't have no idea how a magnet worked to begin with. So if he didn't know how a magnet worked, for him to tell me that gravity works like a magnet, well, yeah. How does a magnet work? Then tell me that. And of course, he never figured it out. He never figured out, how one of these magnets works. But what is the bottom line? The bottom line here is that Ralph Sansbury, the Electric Universe, Walt Thornhill, all these people, what are they relying on? They're relying on the quantum atom. What's the quantum atom? The one used still today, that is still in use today, is the planetary model. Okay, you don't have to take my word for it. Just Google atom images or whatever browser you use, and you'll get a million atoms that are all 100% planetary. Okay, you won't find anything else. That's what the atom is to this day still, after 100 years. Here's an image of that atom. Okay, beautiful atom. Okay, it's got all these little balls going around a little ring. And the question is, what is that ring? What keeps that electron bead, the green one, tied to the nucleus? What physical object? I want to see a mechanism, and I don't see it there. All I see is that they did hocus pocus, and they say, well, the electrons just twirl around or go around the nucleus. Okay, so what keeps them there? Well, some people propose that the atom is hemmed in, by particles from the outside. So it's not that it's attracted towards, but that it's prevented from leaving. What are we going to have? We're going to have particles not only striking the Earth, but also striking, at the atomic level. Are the particles pushing everything inwards, preventing the electrons from flying out and going to another atom? And then, if you have this situation, you're going to have a lot of trouble explaining ionization, why one of those electron beads just leaves. Because if it's being pushed from the outside, what triggers it to leave the atom? But there's an even worse situation, and that's, okay, so this is their atom, okay? It's pushed in by all these ether particles or whatever particles that are on the outside hemming it in. And now we put 4 atoms, okay? And one right next to each other. Well, how come the particles on one push it in and the particles on the other push the other one in? I mean, where are these particles coming from? Why are they going in opposite directions? Okay, we got a little problem here because these people are saying, somehow the particles are being pushed in or kept in there. Okay, and so they have to illustrate that for you. They have to make a movie of their theory or their proposal. How do they plan to explain the mechanism? And yes, we have to explain the mechanism. Okay, now if this was hard, now it gets only worse because now we're going to introduce another orbital. That was the s orbital. This is the p orbital, and the p orbital is the one in the figure 8. As you can go, it goes from east to west, west to east. That's the the p orbital. The other ones are the s orbitals, the round ones. Okay. Now I want you to keep that image in your brain because I'm going to remove now the little rings along which they run. So try to keep the image, okay, in your mind. Here it goes. Okay. Now we remove that, but still we have the figure 8 guy. I hope you see that. Okay. And now let's see if we can get it done with ether. If we can hem these in with ether particles. Huh? Interesting. How do we do that? How do we get the electron bead to move within a certain orbital with just particles from the outside? Are we going to do this all with push? Okay, that's what they have to explain. And well, here we have the flow of whatever, particles, I guess, pushing it inwards. This is what they have to do. They have to tell you the mechanism, okay? And of course, again, if we put 4 atoms, it just gets worse and worse for them. How are they going to explain that? With particles pushing things in, if they're going to use push mechanisms, okay? And then, of course, at the end, just to make things worse, you got the d orbitals, okay? And that's what they look like. And if we put that under, particles pressure, well, it's really a big mess. How are you going to explain this with particles? And that's what they have to explain because they're going to be using that to explain eventually gravity. So that's where they have to start. They have to start at showing you how they can create orbitals. Why the electron beads, if they are discrete beads, why they flow around orbitals, what forms the shapes of the orbitals, which have already been defined by Schrodinger's equation. For those of you who are not aware, Schrodinger's equation is an equation that tells you what the shape of the orbitals are. Okay, that's why he got his Nobel Prize. It was really a good advancement. Okay, but the point is, the Schrodinger never came up with a mechanism, and he never would. Now with particles, and here you see why. They're saying that somehow particles mold each one of those balloons. Can you imagine that? Can you really come up with a mechanism to show me how that's done? And so this is the issue. The issue is that these people, are really skipping the mechanisms because they have no mechanisms. All they have is really a mathematical equation that gives them an idea of maybe how it could work, and then they try to simplify it, like say, yeah, we do it with particles. Well, what do you do? What do you do with particles? Well, we push. And here you see what they have to illustrate. They would have to illustrate how the particles of ether, assuming that's what they're going to propose. I mean, it's up to them. I can't put words in their mouth. I can only try to illustrate what they're trying to do. And are we going to have all these ether particles pushing the electrons inwards, and having them go in these figure eights and figure the s orbital, which is a spherical shaped orbital, and then some of these irregular balloons, such as the d orbital? How can you do this with particles? And anyone who can, well, he should deserve a Nobel Prize for sure. He should get $1,000,000, okay? Because it can't be done. You just simply cannot even imagine. That's why quantum doesn't use real particles anymore. Okay, I'm going to go into some of the comments that some people left last time. See if I got a little time here. And this is one of the comments. A gentleman said, what if every Planck point in space and at every Planck point in time, the universe is expanding at the speed of light in all directions? Matter is the interference, and this expanding force explains gravity as both the pull and push, going through the umbrella and roof of a house and acts on everything. Okay, there's a couple of ideas here. One of them is that they want the particle to go through and also to push. That's one issue. But we got a more fundamental issue, and that's one of the ones that I wanted to address here. Give me a second here so I can pull it out. And that's this issue. Okay. This is the notion that he's referring to. He's saying that a Planck length, and this is what these definitions are in at the Wikipedia and in the officialdom in the mainstream. Planck length, a unit of length, okay? That is the distance. A length is a distance is a length. Yes, in mathematical physics, as you can see, it is. Length, a measure of distance. Distance, a numerical measurement of how far apart objects are or points are, okay? Those are the definitions. So in mathematical physics, a length is a distance is a length, and they say the distance light travels. We're talking about distance travel, okay? In 1 unit of Planck time, and it gives you the value there, okay? Is that satisfactory in science? Can we live with this kind of definitions in science? Well, here's a scientific definition so that you can compare and see what I'm talking about, okay? These are the ones we use in science versus what they use in the religion of mathematical physics. Length, a continuous matter between two surfaces. That's what a length is. Distance is something totally different. Separation between two objects, a discontinuity in matter. I summarize it by saying distance is what lies between two lengths. You have to have two objects, and distance is what is between their surfaces or their center of their centers or whatever, depending where you want to start. But length is something else. Length is when you talk about the table. People, these folks say, "Well, I'm going to unroll the measuring tape and find out what the length of the table is." So he unrolls the measuring tape and he gives you the value in distance. But is he talking about distance? No, he's talking about distance traveled. It's the separation between the ending and starting point in an object that moved. In this case, the end of the measuring tape. That's what they're doing, and they call that a distance. No, that's distance traveled of the end of the tape. And the mathematicians, since they measure everything in terms of meters and seconds and so on, to them it doesn't matter if it's distance or length, because all they want to do is have a value that they can put in an equation. It's in physics where these things are not the same thing. Distance is not a length, so that's one issue. And then we have well, here's the illustration of that. This is the distance traveled. Okay, it's putting tiles. That's what distance traveled is. Another version is that it's the end of the tape of a measuring tape. You unroll the end of it, and that's also a distance traveled. Okay. Now the other issue that this fella had was that he says the universe. Let's put his comment back up here so you have a reference. Okay, and he says. That where is it? The universe is expanding. Well, universe is not a physical object, so you cannot say the universe expands or space expands. Not in science, not in physics, because universe is a concept. It's a concept called that includes two terms: space and matter. That's what universe means. And essentially, space and matter means nothing and objects that exist. Why? Because nothing is that which doesn't have shape, and something is that which does have shape. Okay? So the universe is a concept. What is a concept? The concept is a word that invokes or embodies two objects or two words that are treated as objects. Concepts do not expand. So until he clarifies what exactly he means by the universe and how it expands, okay, we have no idea what object he's trying to expand, okay. And here's one fellow on the internet. His name is Ned Wright. He's a professor at one of these universities, okay. And this is his version of the expansion of the universe. So he's got this balloon analogy, and he says, the balloon expands, and that's supposed to be space-time there. All I see is a 3D globe, and this is supposed to be a four-dimensional space-time that is expanding, and because it expands, all the galaxies, all the stars, all the atoms fly away from each other, including light. In other words, the photon gets stretched. That's what these folks are saying. So this is the notion that mathematical physics has, that the universe, that thing there, that ball, that's supposedly the universe, with all the stars and galaxies and everything on it, expands. Okay, something is blowing it up, and because it expands, all the galaxies are receding from each other, and so is light. Light is getting stretched into the redshift range. Okay. So, these are the things you got to keep in mind when these people ask these questions. Let's see if I can get back in here. Okay. Okay. I think there was another question that someone asked here. That needs to be clarified. And this individual asked, he says, would you explain why mass is not a synonym for object? And yeah, remember mathematical physics treats the word mass as an object. They say, oh, two masses. No. You can say two objects. You can't say two masses. There's no such thing as mass, okay? And I think this throws many off because they have reduced physical objects to mass. That's true. Is it because that which has shape can be massless, two-dimensional object? Not really. The issue here, let me put this up there so that you can follow along. Give me a second here. The issue is that mass is a concept. Okay, let's put this up here. Okay, this is the issue. The issue is that mass is a concept. And an object is that which has shape. And we call it a thing. And a concept is a word that invokes or embodies two objects, okay? And a synonym is a relation. And mass doesn't belong to the category of objects. There is no object, no thing that has shape called mass. Mass is a concept. Obviously, it's a concept. Just like time is a concept, just like energy is a concept, just like the word field is a concept. Mathematical physics has for centuries now treated these as physical objects. They gotten used to doing that, and today, we ended up with uh, all these words being used in lieu of objects. So they talk about, I moved the mass, I transferred energy, the field extends. And this is the problem. The problem is it has to do with language, and this is not philosophy because these people are applying this in physics. They're giving you a physical interpretation in terms of abstract concept, mathematical concepts. That's the issue. And no, mass is not an object. Mass is a concept, and the quick rule of thumb, even though that's not the definition, the quick rule of thumb is, okay, keep this in mind. When you look at a word in the dictionary, any word, does that word represent something that has shape? If it doesn't, it's a concept. If it does, it's an object. So that's the first rule of thumb. And then obviously, anything that is supposedly a relation that requires two objects, a comparison, that's a concept by its very definition. Okay. And what else do we have here? We had, I think, someone else. Someone else asked this question. Another comment here, I think. See if I can answer that. And he says, if we induce a vacuum, we actually don't leave space behind. And what we're saying, what he's referring to, if you have a chamber and you evacuate all the atoms from it, okay, you pump them out. What remains behind? And he's suggesting that, well, maybe the ropes remain behind and the whole thing is filled with ropes rather than with atoms. That's the issue here, okay? So he says what we leave is just electromagnetic ropes with less and less atoms in the chamber as we increase the vacuum, okay? The walls of the chamber are atoms and these are all interconnected right across the chamber. Correct, no doubt about that there. Therefore, what's left behind is not empty space, but just electromagnetic threads. Now we got a problem because the rope is a physical object. That means there is something serving as contrast, or you could say there's nothing serving as contrast and punching, what is it, intended, pun intended. So here, let me give you a little picture that maybe synthesizes what I'm referring to. Here it is. You can see that even though, and I didn't draw every atom that is in there, okay, but even if you remove every atom from the chamber, he is right. The atoms from one side of the chamber are connected to the atoms on the other side of the chamber. This is according to the rope model, okay? They're connected, they're all connected with ropes. But do the ropes occupy fully 100% of the chamber? Absolutely not. They can't. For as many as they are, space is a little more. Okay, and so here I got another picture of this so that you can see why. Here's a rope. Okay, twirling rope, and you can see why. That's a rope. If the rope remained in the chamber, you got to tell me what the white stuff is that gives shape to the rope. What is that white stuff? Well, that's what we're going to call space. Nothing. Vacuum. Okay? So no, it's not that if we remove every atom from the chamber, we leave behind ropes. No, we're going to leave ropes twirling in space, which give background contrast to each rope. Okay? Okay, I'm going to answer some questions. Okay? I still hope someone can hear me out there. Okay, I'm trying to talk loud so that you can hear me. Water purification, the sea, the science have the institute. Okay, comment there attributed to Nikola Tesla. Tesla was a good critic, by the way, of the establishment. That is true. Yeah, I know. Sound is a little too soft. All you can do is turn on the volume. That's all I can do. I'm in the middle of nowhere and I have no microphone. This is it. Okay. Then I have no other questions. Please leave questions if you want, and you got to do that over at Patreon. You do not have to pay. You do not have to do anything more than become a member of or register with Patreon. Okay. So, anyways, I'll see you next time. Hopefully this week, probably at the beginning of next week. Again, I'm on vacation. I haven't even shaved, and so. I'll probably postpone the one on Wednesday till next week. We'll see you then. Ask questions. I'll try to see if I can get a round up microphone somewhere. We'll see you then. Bye bye.